In the last video, we talked about the ARM register architecture. So here we are talking about the programmer's model. So this PDF is the same as the earlier case. It is the manual ARM manual. So it's available in Google. So in programmer's model, some of the portions we had already discussed, like in the register architecture. So this registers, general purpose registers and program status registers we have already discussed. So in this particular video, we'll be talking about data types and processor modes. We talked about many processor modes and which are the registers which will be in use for each of these processor modes that we had discussed. So what is actually the processor mode and what does that imply? That will be discussed in today's video. So data types. So like in 8051, we had talked about unsigned character, signed character, signed integer, single bit, likewise. Okay, so like that, in ARM processor, also you have some data types. You have the byte, half word, and word. So ARM processor, all the instructions, ARM instructions, you have two types of instructions, ARM instructions and thumb instructions. So thumb instructions are more like it occupies lesser space. So they are half word types, half word instructions. So it carries only 16 bits and ARM instructions are 32 bits long. So that is word. Okay, so one word is equal to 32 bits and half word is 16 bits. So that is these two. So why we have this word and half word? That is because ARM supports two types of instructions. One is the ARM instruction, which is the 32-bit long instruction, and the other is the thumb instruction, which is the shorter version of the instruction. Then you have the byte, which is 8 bits. So ARM supports all of these, especially for version 4 and above. And what you need to know is ARM 7. So ARM 7 supports all these three types of data types, and only bytes and words were used previously before the version 4. The half word came into play only in version 4 and later. So you can have signed and unsigned, like in the case of 8051. So unsigned means there is no sign, and signed means you have a sign bit and it will be represented in the 2's complement form, just like in the earlier case we studied. So some of the operations, some of the instructions or some of the data operations are done in the word for quantity, and there are some other instructions which will be done with the half words and some other with the words. Okay, so depending on the instruction, depending on the kind of operation that is done, you'll be using byte operation or word operation or half word operation. So some of the examples given here are all data operations. For example, add. That is, if you are going to operate on a data, on a number, like add, subtraction. So like that operations, that is done only in word quantities. The data should be word size, that is 32 bits long. Then you have operations like load or store. Okay, using a memory location, you want to load or store the bytes of data, then you can use bytes, half words, or words to and from the memory. That is memory access. If you want to store a data into the memory, or load a data from the memory, take the memory out of the read from the memory or write into the memory, then you can use any of these three types. So ARM instructions, like I specified, it is one word, that is 32-bit long, and thumb instructions are half word or 16 bits long. Next, we'll come to the processor modes. So when we talked about the registers, general purpose registers, we are told that some of the registers have two types. Like one is for these modes and the others for those modes. So what are these modes actually? So you have some modes that are supported by the ARM processor. So that is 7 processor modes. So you have 7 processor modes. And what are those 7 processor modes? You have the user mode, that is the normal program execution mode. So normally ARM processor will be in the user mode only, and that is represented by USR. Then we talked a lot about FIQ when we talked about the register architecture. So FIQ, it is a high speed data transfer or channel process. Okay, so that is a special kind of mode which supports high speed data transfer. So that is the second type of mode. IRQ, or the interrupt. Okay, I stands for interrupt. IRQ is actually interrupt request. So it is used for general purpose interrupt handling. Then you have the supervisor mode, or the SVC. It is a protected mode for the operating system. So like just like administrator mode, like that, it is the supervisor mode. So the privileges may be more for the supervisor mode, like that. So it's a protected mode. Abort mode, or the ABT, it implements virtual memory and or memory protection. So deals with memory. Okay, deals with virtual memory and memory protection is abort mode. Undefined mode, or UND, it supports software emulation of hardware coprocessors. So we'll see a little bit about each of these in the coming section. Then you have the system mode, or the SYS. It runs in the privileged operating system task for version 4 and above. So there are some privileged operating system tasks. So that will be run in this particular system mode. So the normal operating mode is the user mode. If you want high speed data transfer, you go for the FIQ mode. If you want general purpose interrupt handling, then you go for the IRQ mode. If you want protected to operate in a protected mode, then you go for the supervisor mode. If you're dealing with virtual memory and memory protection, then you go for the abort mode. And if you are going for software emulation of hardware coprocessors, then you go for the undefined mode. And if you are going for privileged operating system tasks, then you go for the system mode. So how do you change from one mode to another? Okay, ARM processor will be operating in a particular mode. You want to change to another mode. So that can be done by using an instruction software control, or you can do it using external interrupts, or using exception. So these are the three methods by which you can change the mode. Okay, using exception we'll be dealing with in later section in this video. Then you can have external interrupts. Externally, you can give an interrupt to change from one mode to another, or you can write it in a program to that is so when you're writing an instruction, that is taken as a software. So that is software control. So these are the three methods by which you can change the mode. And most of the application programs, so most of the programs will be like we told that the normal program execution mode is the user mode. So that is what is said here. Application programs execute in the user mode only, and when it's in the user mode, it cannot access the protected system resources. That is what we talked about, the supervisor mode. So there are some areas which can be used only when in the supervisor mode. Okay, so those protected area cannot be used while in the user mode. Just like when you say you're using a computer and there is a administrator control over it, the user cannot access the administrator, all the administrator controls. The administrator only can do such things. Okay, so there are tasks which can be done only when in the supervisor mode, but most of the normal operation can be done while in the user mode. Privileged tasks can be done only when in the supervisor mode. So if while in the user mode, if you are in the user mode, say, and you want to use these protected system resources, which normally you cannot use, if you want to use it, then an exception to should happen. So what is exception? That will come. So by the name itself, exception means something which is not routine. Okay, as per routine this should not happen, but then there are exceptions. Okay, to everything there is an exception. So user mode cannot actually access those things, but if an exception happens, then it can do those. So other than the user mode, so we talked about 7 modes, and other than the user mode, other the rest of the 6 modes are privileged modes. So unprivileged mode is the user mode, and the privileged modes are the other 6. That is FIQ, RIQ, supervisor, abort, and undefined. And the privileged modes all have full access to system resources and can change mode freely. And 5 of them are known as exception modes. So 1, 2, 3, 4, 5. These 5 are called the exception modes. So only the system mode is not a system mode, and the user mode are not exceptions. Other 5 are exception modes. Other than user mode, all the rest is privileged mode. And in the privileged modes, other than the system mode, others are all exception modes. They have full access to everything, and they can change modes freely from one to another. So in system mode, it is present only in version 4 and above, so it's there in 7. It is not entered by any exception and has exactly the same registers as in the case of user mode. So system mode has the same number of registers as available in the user mode, and you don't enter a system mode when an exception happen. That is why it is not called a exception mode. But it's a privileged mode, though not an exception mode. It is a privileged mode. So the restrictions you have in user mode, that does not apply to the system mode since it's a privileged mode. So this we have already talked about the registers. You have the status registers, the general purpose registers, 37 registers and all. So this is what we talked about just now. Okay, so user mode is the only unprivileged mode. Rest 6 are the privileged modes, and except the system mode, all the rest of the privileged modes are all exception modes. And we also talked about the registers used in these modes. So R0 to R7 is unbanked, R8 to R14 is banked, 15 is PC, so these we have already talked about. R13 is normally used as the stack pointer, R15 is the program counter, and then you have the program status registers, of which from 26 to 8 these bits are not used. It's for future use. You have the negative 0 carry overflow Q, you have the IFT, then the modes. This we have already talked about. You can change from mode to one mode to another using a software by changing the bits in the status register like this. So we've been talking about exceptions here and there. So what is actually exception? So exceptions are generated by internal and external sources to cause the processor to handle an event. An event happens, which is not a normal event. Something happens. For example, an externally generated interrupt. So in the normal routine, an interrupt does not happen. But then when a special case happens, when an event happens, an interrupt can happen. So say an external interrupt happens, or there is an attempt, or the program is trying to execute an undefined instruction. So any such exceptional thing happens, then an exception will be generated. So when this exception happens, so the processor is actually executing a normal program. So it's just like when we talked about in the first module, we talked about interrupts. So interrupts we talked about, like you're executing, the CPU is executing the main program, then an interrupt comes. It can be a software or a hardware interrupt. What will it do? It will preserve all the data, like the contents of the program counter or the status register. Everything will be pushed into the stack. Go handle the interrupt. The interrupt service routine will be executed, then it will come back, it will pop out everything from the stack and then resume the normal operation of the program. So that was interrupt. So this is somewhat similar to that. So exception handling is also done using a subroutine. So just before handling the exception, the data must be preserved so that the original program can be resumed when the exception routine is similar to the interrupt service routine, which we have already talked about. Exception routine is just a set of programs, set of instructions or a small program. And more than one, just like more than one interrupt can happen at the same time, more than one exception can also happen at the same time. So whatever data you need to resume the execution of the normal program, those data should be preserved. Maybe the content of the carry flag, content of the overflow flag, or the program counter, that address. So all these, there are some register addresses when the registers are going to be used in the subroutine. So all these values should be preserved somewhere. Then it will go and service that particular routine, that other program, and come back and resume the actual program. So it should be preserved, and ARM supports 7 types of exceptions. So these are the 7 types of exceptions. You have the reset, undefined instructions, software interrupt, prefetch abort, data abort, IRQ or the interrupt request, FIQ or the fast interrupt. So these exceptions will be operated, will be uh, in only these modes. So reset happens in supervisor mode. Undefined instructions happens in undefined mode. Software interrupt happens in supervisor mode. Prefetch abort and data abort happens in abort mode. IRQ happens in IRQ mode, and FIQ or the fast interrupt happens in the FIQ mode. So these are the 7 types of interrupts. We also talked about the different types of modes. We talked about registers. We talked about what an exception is. So what are the 7 types of exceptions that can happen in the, or that can be that is supported by the ARM processor? These are the 7 types of exceptions, and these are the modes in which they can occur. So after handling the exception, to return to the main program, the status register is moved into the CPSR and R14 is moved to PC. So these data is preserved. Then a small note on what do these interrupts mean or exceptions mean. So reset. When the reset input is asserted on the processor, the ARM processor immediately stops the execution of the current instruction. So you have a reset input for the ARM, and when that is asserted or that goes high, then the ARM processor will stop whatever it is doing right now, and it will go and execute the exception routine for the reset. And when the reset input is deasserted or becomes 0, then these things will happen. So after the, you needn't actually know about these, just understand what the reset exception is. So after reset, the ARM processor begins the execution at 0 or FF0. Then you have the undefined instruction exception. If the ARM processor executes a coprocessor instruction. Okay, ARM is a processor, you have a coprocessor, and when the ARM is executing a coprocessor instruction, then it will wait for any external coprocessor to acknowledge that it can execute the instruction. That is, ARM is trying to execute the instruction of another processor, and that processor is called the coprocessor. So the coprocessor should give privilege or should allow the ARM processor to execute its instruction. Okay. The coprocessor has a set of instructions. ARM has another set of instructions. ARM is trying to execute the instruction of the coprocessor. So the coprocessor uh, should allow the ARM processor to do this. So that is the first line. If no coprocessor responds, an undefined instruction exception. So the ARM processor is trying to execute the instruction of a coprocessor, but the coprocessor is not giving the acknowledgement, is not allowing the, is not giving a, okay, you can do it, that kind of a signal to the ARM processor, then an undefined instruction exception will happen. Then you have the software interrupt exception. So the software interrupt instruction enters the supervisor mode to request a particular supervisor or the operating system function. So when this software interrupt is executed, the contents of the PC will be stored somewhere, and after the execution of this exception, that will be given back to the PC. And also the status register contents will be preserved in the CPSR. Then you have the prefetch abort. So if a memory system signals a memory abort, so if you have a instruction fetch, and if the fetched instruction, uh, sorry, if there is a instruction fetch, if you're going to, if the processor is trying to fetch an instruction from the memory, and at that time an abort is given, a memory abort is given, then that fetched instruction will be treated as invalid. And if the processor tries to execute this fetched instruction, which is treated as invalid, then an prefetch abort exception will happen. Okay, so the processor is trying to fetch a instruction from the memory, but at that time memory abort, that particular signal goes off. So when there's a memory abort, that means that whatever was fetched from the memory, that is treated as invalid. And the processor, after fetching it, it tries to execute this invalid instruction. At that time, a prefetch abort exception will happen. So if the instruction is fetched but not executed, then prefetch abort does not happen. Data abort is, suppose you're trying to access the memory to fetch the data from the memory or to store the data into the memory. So it's a memory access program. So at that time, if a memory abort happens, then that data is treated as invalid. Earlier it was instruction, now it is data. Both in the case of memory access. Then you have the interrupt request exception. So that is sort of a hardware interrupt. So in the this is an externally generated interrupt. Okay, so you have a pin, input pin called the IRQ pin for the processor. So if that pin you apply a 1 or you're making that high, then this particular exception will happen. And if suppose you have IRQ and FIQ, both happens, then FIQ will be serviced first, then only IRQ will be serviced. If two exceptions are happening at the same time, IRQ and FIQ, then FIQ will be serviced first, then only IRQ will be serviced. Like we told earlier that IRQ and FIQ or any two exception or more than two exceptions can happen at the same time. Then these will have a particular priority, and depending on the priority only the exceptions will be serviced using the corresponding service routine. Then you have the FIQ or the fast interrupt request. So this is a higher priority when compared to IRQ. This is also generated externally by SI asserting the FIQ input on the processor. So processor has these two pins, IRQ and the FIQ pin. So if there is an assertion, a hardware interrupt coming in at any of these pins, then that particular exception will happen. If it happens at the same time, then FIQ will be serviced first. So this is the priorities of the exception. So the highest priority is for reset, then the data abort, then the FIQ, IRQ, prefetch abort, and last is for the undefined instruction or the software interrupt. These two have the same priority. So this is the priority list.